Okay, good morning everybody. Hope you're doing well. Hope you had a nice weekend. Let's begin. And first of all, I wanted to remind you that the Virtual Career Expo is tomorrow for engineering and science majors. And the way that you can register for that, because advanced registration is required, is you should go to marshall.joinhandshake.com. And everybody listening to this has some kind of an opportunity that they can learn about at the Virtual Career Expo. Even if you don't plan on doing a summer internship, still it's a good idea to start to get a feel for what the employers are looking for, where the opportunities are, and what kind of work you could be doing after graduation. And so I'd really encourage everybody to learn more about the Career Expo, participate. It's tomorrow from 11 till 2. So definitely take a look at that. With our course-specific announcements, you've just submitted homework number 7, and homework number 8 is due a week from today. And that assignment is posted now. It includes some more in-depth questions, and so there's a fewer number of questions, but some of them are worth 15 points each because those questions are a little bit more lengthy. So I'd encourage you to get an early start on that assignment. After today's in-class exercise, for example, you'd be in a good position to begin on some of those problems. And a couple of them are just kind of bond questions to keep it fresh in your mind, because I think from my experience, bonds are something that are a little bit abstract and difficult for the students to understand up front. So homework 8 includes 2 more bond questions as well. And then I didn't receive any project-related questions over the weekend, but if you are working on your project and you want to double check with me to see if your spreadsheet is set up correctly or whether some of your cost estimation estimates are reasonable and what I'm looking for, just reach out and I'd be glad to go over it with you. Okay, so in today's class what we're going to do is we're going to look more at why we shouldn't use the internal rate of return as a project selection tool, and why instead it is limited and restricted to being kind of an initial screening for suitability and acceptability. So that'll be the first part of what we do today, is another example with the internal rate of return and a couple of projects that illustrate the restriction we have to follow. And then the second part of today's in-class exercise is an external rate of return practice. So we're going to get practice with both of those, and they're both important methods. So that's why we're spending a little of extra time on those ideas. And so let's review conceptually what happens in a case like this. So let's say that your company made an investment now. You can see here the investment is $285,000. And then it expects some return over time. And so in this illustration, you've got $50,000 each year that's going to be coming as a result of the investment. So those are the profits in the future. So if your company did that, what are you going to do with the extra $50,000 each year? That's the question you need to ask when you're considering whether to apply internal rate of return analysis or external rate of return analysis. And so if you're going to reinvest that money back into the same account or back into the same project or a project that generates the exact same return, then it is suitable for you to use the internal rate of return. And so the word internal implies that the profits are recycled within the project. And so an example of something that is suitable for internal rate of return is if you're going to be reinvesting the earnings from a savings account back into, if you're reinvesting the interest and you're leaving it in the account, then internal rate of return is what you'd get. But if you're going to be moving the profits that you earn into some other opportunity or into a different account that pays a rate of return that differs from the rate at which the profits were generated. So we call that the external reinvestment rate. So if there's some external place that you're putting the money, then you need to use external rate of return in order to compare projects and understand really what's the weighted average rate of return on your capital investment. So those are the assumptions that play into whether we go with IRR or ERR. So that's a review. Now here is a review of the external rate of return method. We went through this step-by-step approach during the class on Friday last week. And so you're given some cash flow over time. It may be a cash flow diagram, it could be a table, or maybe it's just a paragraph where it's explaining the initial purchase, where it's explaining the anticipated revenues and so on. So overall, what we want to do is we want to move the outflows, meaning anytime we're spending money, we're going to discount that to year zero, to the present, and we're doing it at the given I sub I, and that's the external reinvestment rate. That's the rate that your profits is earning when they're reinvested some other place. Now, one caution that's important is that if there is an amount that's both a revenue and a cost in a given year, so you see that this amount has both an arrow up and an arrow down, then you'd only move the net amount forward or backwards in time. And so this small arrow is less than the revenue in that same year. And so we wouldn't discount this small cost to the present. Instead, what we do is we'd reduce the amount of the revenue in that year by the amount of the cost, and then the revenue would be compounded into the future. So the outflows go to the present, the inflows go to the future, and in both cases we're using the known given external reinvestment rate. So that's the interest rate that's in the problem statement. It's not the one that we're trying to solve. The external rate of return is the unknown. The reinvestment rate is given. So you've converted your cash flows over time into a lump sum amount at the present and a lump sum amount in the future. The third step is that you're going to now try and find out the unknown external rate of return by discounting that amount that's in the future to the present at some unknown interest rate. So you keep playing around with the interest rate. You start off with a guess, maybe 1% or 2% as a starting guess. And then you use goal-seek to keep changing the interest rate until the magnitude of the present value of the sum of the revenues that have been compounded to the future. So in other words, this arrow, you want to discount it to the present at a variety of different interest rates until you find that the sum of the amounts at time zero is equal to zero, so that the inflows and the outflows are equal in magnitude, although the sign is different. Okay, so that's a summary of the process that we use for external rate of return. We're going to practice both today, internal and external. Remember, here is how we translate that step-by-step method into a spreadsheet template. A few minutes before class, I emailed you another Excel file just today. And the purpose of me sending that is just to speed up how quickly we can work through today's in-class exercise. It saves you the time of like formatting and labeling the columns, and instead we can jump straight into the math. Before we get into today's in-class exercise, are there any questions about the method that you should use on the external rate of return analysis? Any questions about this procedure or the spreadsheet template? Any questions at all? All right. Now, what I want to start with today is an illustration that proves that the highest internal rate of return isn't necessarily the project that's best for you. The definition of the best project for a company that is for profit is that the best project is the one that maximizes your profit. So you don't necessarily want to maximize an interest rate, you want to maximize the number of dollars that are coming to you. Now sometimes the highest internal rate of return also is the project that gives you the most profit. But there are instances where a project that has the most profit actually has a lower internal rate of return than a less profitable project. So that's what we're going to look at today as an example of why you shouldn't use the internal rate of return for anything other than initial screening. You can use it to give yourself a thumbs up or a thumbs down as to the suitability of a project, but you can't use it to pick alternatives. So the in-class exercise that we're going to look at for comparing projects according to the internal rate of return, let me bring it up onto the screen, and I hope that you have a printed copy for your convenience there in front of you as well. Okay, so let's look at the scenario. You can see that I've given you the warning here that, although we're doing it for purposes of illustration, just to make the point that you shouldn't compare IRRs, I'm just warning you that ordinarily that's not going to give you the project with the highest profits. That's what we'll find as the conclusion of this exercise. All right, so we've got project A that has an upfront cost of $50,000, and then it returns $9,000 a year for 10 years in a row. And comparing that to project B, where the purchase price is $85,000, and then it entitles you to an ongoing revenue of $14,000 per year. We know in the problem statement at the top here that our company's minimum attractive rate of return is 4%. And so the way that you should use internal rate of return is to check whether the IRR is greater than the MAR. Remember decision criteria. That phrase, it means it's the standard that you use to judge a project. And so the decision criteria for internal rate of return is if the IRR is greater than or equal to the MAR, then the project is suitable. So let's do that. Let's calculate the IRR for both of these projects, and not just with the IRR function. That would be too easy. Let's get a little bit of practice reminding ourselves really what is the internal rate of return. It's the interest rate that brings equilibrium between the inflows and the outflows. So we'll set up the full method, which let me bring up the template that I sent you. Okay, so I think this is what it looks like that I sent to you. Just to verify, did that message come through? Have you got it? Over the weekend I got an email from Blackboard that I thought I had sent out to students quite a bit earlier, so I just want to check. All right, thanks Julian. James has got it as well. Trevor has it. Good. Okay, so this is the template file. So what you should do is, I'll pause for a moment so you can think through this without my constant yammering. Translate our problem into using the template file here. And so we want to know what interest rate gives it so that the total is 0. That's how you know equilibrium between the inflows and the outflows. And so you'll have the amounts, you'll have the present value of the amounts, and then the total is the sum of all of those. And so by changing around the interest rate until you have a total that's equal to 0, then that is by definition the internal rate of return. All right, so I'll pause for a moment and give you a chance to get started on this. And then if you have a guess for what is the internal rate of return for A and B, go ahead and type it into the chat box there. And then after a few minutes, I'll break in and I'll start illustrating the solution as well. Okay, well, I don't want to drag this out too much longer than is necessary. So when we're doing the internal rate of return, we have to start with some guess value for the internal rate of return. So just as a placeholder here, I'll put in 1% for both the one that we're going to use for A and 1% for the value that we're going to use for B. Now we just translate in the given amounts. So minus 50,000 is the given amount for project A, and then an annual revenue of 9,000, which continues onward through year 10. And the amounts for project B, minus 85,000 and 14,000 recurring. Using the PV function, we want to refer up to the interest rate for this particular project, and I'll anchor the reference since I will be dragging the formula down through other rows. N refers to the year itself, since any of these future amounts will need to go n years to get back to the present. Skip over the payment field, because if I put it into the payment field, if I referred to the amount within the context of the payment field, it would think that there are n payments. But rather, what we do have is a single future value that's being discounted to the present. So that's why I put the minus sign, and I refer to the given amount inside of the future value field. All right, so now if I drag this down through, you can see what we would expect, that these future values become increasingly less valuable, that the longer time goes on, the more value is eroded because of the interest rate. And so now what I can do is apply the same formula over here to B, equals PV, refer to this rate at the N for the year, double comma, minus of the amount, dragging it down, and now the sum equals SUM function for all of it. And if it's positive, then that tells us that the interest rate is too small. So it means that these future values aren't being discounted enough relative to the zero that we're looking for. We're looking for equilibrium. And so let me also do the sum over here. All right, so project A, its internal rate of return can be determined using the data tab, what if analysis, goal seek. And so the goal seek that I'm going to tell it can do is set the total to a value of 0 by changing the interest rate. And so as soon as I click OK, it'll begin monkeying around with the interest rate until it finds that the total is 0. Takes a second to find that it's 12.4%. And then if I repeat that process over here for project B, set the total to 0 by changing this interest rate. Our interest rate's 10.3%. All right. Oops. I should have said OK rather than cancel. Goal seek. Set the total to 0 by changing the interest. Okay, okay. So here's the main point. A student maybe, or not even a student, anybody who doesn't know about internal rate of return could say, well, you're choosing between option A and option B. You know, option A has a higher rate of return, so you should go with option A. That's maybe the false conclusion that you would draw. But really, the true conclusion that you should draw is that both projects have an IRR greater than the MAR, and so each of them will be profitable, and they're both acceptable. Both projects are acceptable. But that doesn't mean that one is better than the other according to what we've just determined here. Now, to make that point, what I ask you to do in the next step is to calculate the present worth of each project. Now, you can do that with Excel, or just maybe to dust off the factor method, you can use the factor method here. I've given you the P/A factor is 8.1109, and what that means is your present worth will be 50,000, which is already at time 0, plus $9,000 each year multiplied by the factor. All right, so let me pause for a second and give you a chance to determine the present worth of both projects at the MAR. So what's the the present worth at the MAR for both of these options? I'll show you both the hand method and also on the spreadsheet. So what's better, project A or project B? Well, we're not going to be tempted to just choose which one is better based on the internal rate of return, because we know better than that. We know you don't choose a project based on IRR. You choose a project based on profitability. And so how profitable is project A? If your interest rate is 4%, meaning maybe you borrowed the money from the bank at 4%. If that's the case, then the present value of your profits is $22,998 for project A. But the present value of the profits for project B is greater. So project B is the superior option. If these are mutually exclusive alternatives, meaning that you can only do one of them, the project you should do is project B, not project A. Now, how would we solve for that same thing with the spreadsheet? Well, what is the present worth of the profits if we're at 4%? 22,998 versus 28,553. So here's my question to you. Why is it that project B is better? Like, why is it more profitable? Does anybody see what's going on? Like, why is it that one project can have a higher interest rate, but the other one can have a higher profit? It's not immediately obvious, but it's like this. What if you could go to one bank and they were like, you're opening a savings account, and bank number one says, we will pay you 8% interest on this account. And you're thinking, wow, that's really great. I'd love to have a bank account that pays me 8% interest. But then they say, but you're only allowed to deposit $1,000. Whereas a different bank will pay you 5% interest, but you can deposit $100,000. Which of those two options is going to end up giving you more interest if you can only choose one of them? Well, it's the one where you're able to invest more money up front. And so of these two projects, project A and project B, you notice project B has a bigger investment. And so it's more profitable if you're able to invest more money up front and get these larger profits. So it's better to get $14,000 every year than to get $9,000 every year. It's proportionally better in the case of comparing B and A. The proportion of the profit to the original investment is greater for project B. So if we discount things at the MAR, meaning you went out and you had to borrow the money to do these projects, if you pay back the bank the interest that you owe them, then these present worths represent the value that you get to keep. It's the present worth of your profits after covering the interest that's going to the bank. And I think that's one of the questions on your in-class exercise. So explain which project should be selected and why. So, there are concept questions on the exam, and you need to be able to explain why project B is better. So some of the ways that you could say it: project B has the greater present worth, and it should be selected because it allows for a greater upfront investment. It has more profits. And so then this concept question, I just addressed that. If you borrow money at the MAR, then the present worth represents your share of the profits, because this revenue that's coming in over time, the $14,000 that you get every year, some of it you get to keep and some of it goes to the bank to cover the principal and interest for your loan. And so the value of your portion is this present worth. So are there any questions about the first problem before we move on to the second one? Anything that wasn't clear, or maybe a step in the spreadsheet that you'd like to see again? All right. For the next part of our in-class exercise, let's revisit the external rate of return and get some practice with that. It's really an important concept and it's complicated. I mentioned to you that I consider this to be maybe the most complicated procedure that you're going to do this semester. And eventually you need to be able to do this starting with a blank spreadsheet. You know, I've given you a template file today where everything's kind of set up nicely and you're just going to have to put in the numbers and enter formulas, but you should be able to understand this well enough that you're given a cash flow diagram without any spreadsheet template, and then you could just start Excel and from a blank workbook determine the external rate of return. That's the point that, you know, if you understand it well enough, then you can do that. All right, so, but this time around, I did give you the template. So go to the tab that says ERR Start, and we've got our cash flow diagram pasted in, as well as all the column titles that are going to be applicable for this. All right, so we went over this method on Friday. I don't want to belabor that point right up front. What I'd like to do is pause for a moment and allow you to start solving the procedure. Remember, present worth of the outflows, future worth of the inflows, and the interest rate that we use for both of those is the external reinvestment rate. And then when you have a moment to do those calculations, I'll jump back in and I'll start working through my procedure and we'll see if you're on the same page. But if you've got a guess for the external rate of return, because this is ultimately what we're trying to solve for, go ahead and put it in the chat box and I'll give you the thumbs up if you've got it right. So we've got our cash flow diagram, and the one tricky year that we're going to have to pay special attention to is year 5. And the reason for that is that it's the net amounts that should either be discounted or compounded, and there's both a revenue and a cost in year 5. So we need to pay special attention to that. Now the secondary time column we're going to use for the future value calculations for the inflows, and so let me set that up first. I'll start it with 9 minus whatever year we're in, and then that'll tell us how many years it is to get to the future. So the amount that's in year 9 will be compounded 0 years to the future. But for instance, the revenue amount in year 2, that amount is going to be compounded 7 years into the future. So that's our reverse time column here. Now, I don't know, maybe this column is kind of redundant since I'm going to be typing in the outflows and the inflows, so maybe I'll just skip over that entirely. We've got an outflow of 15,000 in year 0, and then there is in year 5, 8,500 minus 5,500, so there's 3,000 net outflow in year 5, and then 8,500 net in year 6, and that's all of the outflows. And so then the inflows, there's nothing. All right, 5,500, 5,500. Okay, we don't put that amount in year 5 because it's the net difference that has gone into the outflows. But then in year 7, that's when the real revenue kicks in. We've got 22,000, 28,500. And 33,000. I'm not sure what kind of investment this is, but it sure pays out a lot at the end. All right, now the external reinvestment rate. This is the given interest rate that's mentioned in the problem statement, 3.5%. So all of the profits that's being generated by this investment opportunity, the profits can't be put back into it. They have to be invested externally. And we're told that the account rate is 3.5% for that external account. So we will now use the PV function for any of the outflows at the external reinvestment rate. N is how many years it needs to go to get from wherever it is to the present. Skip over payment field and minus of the amount. All right. So we distribute that downward through all of them. And the trend that we would expect, the future amounts are less valuable when they get to the present. So it is discounting them. And for compounding, we should see the opposite of that. The further away from the future they are, the greater the amount. So for instance, this 5,500 should be worth more than this 5,500 because it has more years to compound into the future. So I'm going to do the FV function using this external reinvestment rate. N is now going to be our reverse time column. Skip over the payment field, and now the present value that we should apply this formula to is the minus of the inflow amount. And so when we apply it to the years where there actually are amounts, sure enough, that first 5,500, since it has more years to compound till it gets to year 9, it's a greater number of dollars. And then we do the total, so the sum of all of these. I can just drag this formula sideways and it'll apply the same sum as it did to the left. Now, the external rate of return is initially a guess. 1% is as good a guess as any. And then this last thing, what we're doing is we're going to take this lump sum future amount and discount it to the present at the external rate of return. So we're using the PV function at the guess interest rate. Now for N, how many years in the future is that lump sum amount? It's all been compounded forward to year 9. So it's going to be 9 years to move it from its future back to our origin point of year 0. So 9 years, and we're skipping over the payment column and minus of this lump sum future amount. Okay, so 1% isn't discounting it enough. What we want to find out is the interest rate that makes the sum, which has been discounted back to the present. So this, we're looking for this to be equal to the cell shaded in green. And so now I'll shade this in green just to make it obvious. It's good, you know, when you're making a spreadsheet like this, put little breadcrumbs along the way to remind yourself of what you did, or remind the grader who may be looking at it so that they're able to understand that you understood. All right, so we're going to look for this to be equal to that by changing the interest rate. So 2% gets me closer, 3% gets me closer yet, and then the automated way to do it without repetition, data, what if analysis, goal seek, set this to, now I have to type in the amount. For whatever reason, I can't click in the cell, I think because it would see the formula rather than the amount. So I'll type in 24,440 and 67 cents by changing the interest rate 17.75%. And several of you got that same amount. So that is our external rate of return. So what is that? What does that even mean, 17.75%? Well, it's the overall rate of return. That takes into account the rate at which the profits are generated. And so what I mean by that, the rate at which profits are generated, I mean you put in a certain amount of money and then a certain amount of money comes out without yet factoring in the effect of compounding. So this overall weighted average takes that into account. It takes into account how big are these income arrows relative to the expense arrows. But then it also takes into account the external reinvestment rate. So it's taking into account the effect of compounding. When you take your profits and you put it in some other project, if you have a really big external reinvestment rate, then that'll bring up your external rate of return. So this interest rate is a weighted average that's taking into account the external reinvestment rate and also the cash flow diagram. So we've had some practice today. We've had practice on the internal rate of return, the external rate of return. We learned more about why you can't just go by the IRR. Just because a project has the higher IRR does not mean it's going to be the most profitable. And maximizing profits is what you're after. You're not after maximizing interest rate. You want to maximize profits. All right, so that's it for today. Remember that the Career Expo is tomorrow. You should definitely get on that. Do yourself a favor. And yeah, I'll go back to the ERR sheet in just a moment. And then the other announcement to keep in your mind is the homework assignment due on Monday. All right, that's all I have for you today. Have a good one. And